It's all right. So we want to figure out what angles here are supplementary to ALJ. And so I'm just going to highlight ALJ to make it a little bit easier to talk about. You can redraw it. No, too much work. It's not the same. All right, so we're looking at that angle. That's ALJ. So we want to think about what angle will help create supplementary. Means they have to add up to 180, right? Well, one way of doing this is to realize and remember that 180 visually is a straight line, correct? As an angle, okay? So if I'm looking at that line right there, okay, what angle do I have to add to that so that I can go from this all this yellow and then plus what will give me that green line, and it should be that angle there. Does that kind of make sense? Yeah. Those two angles added together should give me 180. Okay, so we'd be looking at angle ALB if we look at that line. But now the issue is I could also be looking at maybe that straight line, okay, or straight angle, which is also going to be the yellow one plus this blue one. And those two together will get me from there all the way over there in regards to an angle kind of tracing itself out, excuse me. And that would be 180 degrees as well. So we'd be looking at angle JLP. Does that help? Now they say supplementary here. Remember, supplementary doesn't necessarily mean that they have to be adjacent. Okay, I could have, let's say, right. So those two angles would be adjacent, right? And they together create that 180 degree angle, so they are adjacent and they're supplementary. But two angles could be, let me kind of replicate this real quick. So I just kind of cut and pasted to make those angles mirror the ones that were adjacent and supplementary. So these are still supplementary. Does that kind of make sense? But they're no longer adjacent. All right. So those two are adjacent and supplementary, and when that happens, they create a special type of supplementary angles, and these we call a linear pair because they form this line, this horizontal line there. But going back to that last question, though they just say supplementary, we would maybe want to go through this and say, okay, we looked at just adjacent angles, right? Okay. And right now we want to say, okay, if we look at just the adjacent angles that help make that be supplementary, that's fine. Those work. That they are supplementary. But now I'm going to go through here and I say, okay, that's 90 degrees. Would you guys agree with that? Or sorry, not 90. 90 plus 60, so it's 150. Okay? So now, if I can find another angle up there anywhere that is 30 degrees, will the 150 and the 30 be supplementary? Yeah. Okay? But the issue we run into is there's no angles up there that we can, other than JLP and ALB, that we can identify as being 30 degrees. Does that make sense to everyone? We can, now they don't tell me JLP and they don't tell me ALB, but we know that they form that straight line. Okay? At least these three angles form that straight line. If that's 90, that's 60, that's 150. If you get 180, then that has to be 30. Even though those numbers are not too. Okay? So we want to look through the rest there and see if there's any other 30-degree angles that are not necessarily the ones we listed, and there aren't. Okay? There may be at some point. One thing I ask you tomorrow, a question that is on tomorrow's test, is phrased, True or false? Come on. True or false? All supplementary angles are linear pairs. True or false?
True.
All supplementary angles are linear pairs. Supplementary is when they have 180. Linear pairs is when they're together and they form a line, right?
Yeah.
That's false. If I have, let's say we go to it's kind of easier to draw them in GeoGebra than anything. Let's say I have that angle, and let's create another one. Given size, let's use beta. Yes. Say again? Okay, hold on a second. So if I got these two angles, 57.3 and 57.3 again, well, that's not doing what I want to do. There we go. All right, so let's just look at those two angle measurements. Can you guys all see the 57.3?
Yeah.
Okay, and the 80.2. So let's say that I take the 80.2 one. Let me just change these properties and make this a little bit easier. Object properties. All right, so let's say that, well, that's dumb. Yeah. That's okay. We'll be all right. All right, well, I apologize that this is not doing what I want to do. All right, so that angle is 66.73 degrees, right? Let's create another angle. I'm not very good at the angle tool. I don't use it enough to, and it's all the angle that it shows is all dependent on the order in which you create the points. Okay, so I always forget what order I created points with. So let's say that I start with something like that. Okay, that angle is 116.57, and I take and try to fit next to it or on top of it another angle that helps me create a straight line. So the straight line that I'd be looking for would be that line there. So if I could take and put C on there, you see that those two angles now, okay, if I add those together, I'm going to get roughly 180. Now there's some rounding there, but roughly 180, right? So those are supplementary if I add them together, but they are a linear pair because they help create that line, right? Does that make sense to everybody? Okay. So let me attach that point real quick. Attach that to there. And now you see that 116.57 and add to 63.43. It will give me 180 degrees, correct? So they are supplementary, and because they form this line here, okay, because they form that line, no matter where I move them, they're always going to be supplementary, and they form a line, so they're a linear pair. Does that make sense? Yeah. Linear pairs are always supplementary. But if I do this, if I get rid of that line, see if this works the way I want it to. It didn't. Okay, if I get rid of that line, let's go. Let's do this. Let's go. Control C. B. All right, so I take those two individual angles that we just had that were together, and I do this with them, and I just reposition them. Is this one still 111.21? Yeah. Is this one still 68.79? Yeah. Yeah. Do they still add to 180? So are they still supplementary? Yes. But are they a linear pair? No, they're not. They're not stuck together. They're not adjacent to be a linear pair. They have to be adjacent to be a linear pair. They can still be supplementary. Is that all right, everybody? But once they're adjacent, they become a linear pair. So the question is, okay, all supplementary angles are linear pairs. Well, these are supplementary. We just said they're not a linear pair, right? So the answer to that question would be false. But what if I ask this? All linear pairs are supplementary. True or false? That's true. Okay. I just reverse the order, right? Okay. So if you start with a linear pair, so we're thinking about what we start with. Start with linear pairs, well, they have to be supplementary. That's a rule that we have. So if I start with supplementary, all that means it's two angles after 180, and there's no criteria in how they have to be orientated with one another. Because we developed a rule that says linear pairs have to just equal 180. They have to be supplementary.
So, what do you call it when they're next to each other?
We really don't have them. We just call them adjacent complementary angles. We really don't have a special name for them. That's a good question. Okay, so what you're always asking is if I have a picture that looks like this. Where we have a right angle, okay? Two angles have to be 90 degrees of complementary, right? Yeah. So he's saying if we have that, and they're adjacent, kind of like we do with linear pairs, how come we don't have, or is there a name for that group of angles? And there like, especially like linear pairs, there is not a special name, okay? We just refer to those as complementary adjacent angles, or adjacent angles that are complementary, okay? Where, in contrast, if you have supplementary angles that are adjacent, we have a linear pair, right? Okay. So there's no real additional tag word or definition that we use for right angles. It's a good question. And I'm assuming that we don't have that because it doesn't. We use the feature or the fact about linear pairs so much in this course, and it's so prevalent that it's just easier to talk about them that way. So my assumption is because this doesn't happen that often, and we don't need it that often, that we don't have a name for it. Anything else you guys want to talk about? Any other questions? No? We good? Everybody's good? If
It looks like